all of you. Welcome to the GATE 2024 Signals and Systems problem solving session. The first question they are given is a causal and stable LTI system with impulse response h of t produces an output y of t for an input signal x of t. A signal x of 0.5 t is applied to another causal and stable LTI system with impulse response h of 0.5 t. The resulting output is dash. These are the options given. Okay. So, first, they have taken one LTI system whose impulse response is h of t. Okay. Yes. For this, the input is x of t. And from this, we are going to get y of t as output, and we know the basic equation y of t is x of t convolved with h of t. Okay. In that way only we are going to get the system output, LTI system output. And in the second case, LTI system of impulse response h of 0.5 t is taken. For this, the input is x of 0.5 t. Yes, now we need to find the y of t. Okay. So, if you compare this and this, the difference is the time scaling. Here the time is t and here the time is 0.5 t. Okay. So, we know the basic convolution with the time scaling. The convolution with the time scaling is, see here, when there is no time scaling, this is the convolution, yes, you have to do to get the output. But if the signal is time scale, then the relation is x of at convolved with h of at. We are going to get 1 by mod a y of at. Very simple expression. Okay. So now what is our x of at? Is x of 0.5 t. Okay, means it implies a is 0.5. Okay, then convolve with h of 0.5 t. Here, see here, h of 0.5 t. So, you are going to get 1 by mod a. What is mod a? Mod 0.5 into y of at, that is y of 0.5 t. So, what is this? 1 by 0.5 is nothing but 2. So, 2 into y of 0.5 t is the result of the convolution x of 0.5 t and h of 0.5 t. Okay, so what is this output? This output is 2 into y of 0.5 t. Okay, yes, and the given options, the option A is correct. Okay, so the answer is 2 into y of 0.5 t. Yes, the next question is, consider two continuous time signal x of t and y of t as shown below. This is your x of t and this is y of t. If x of f denotes the Fourier transform of x of t, then the Fourier transform of y of t is, means you have to, if you see the options, so you have to express the Fourier transform of y of t in terms of the Fourier transform of x of t. Okay, means to get the Fourier transform of y of t in terms of x of t, first you need to relate the x of t and y of t. Okay. So, now what you have to do? You have to convert your x of t into y of t by applying some conditions or by applying some transformations. Okay. Now, if you observe x of t and y of t limits, y of t is between -2 and 2. Totally, the limit is 4. But here if you see x of t limits 0 and -1, total is only 1. Okay. So now what you have to do? You have to scale your x of t. Like, yes, first you have to go for x of, see, this is only 1 and this is 4. So you have to go for t by 4, x of t by 4. Okay. Means the scaling factor, yes, a is here 1 by 4. Okay. Means this is like x of at. Okay. Now I will draw x of t by 4. Yes. x of t by 4 I'm drawing. Yes. See, this becomes minus 1 is the actual time point here, and you have to divide it with a, means minus 1 by a. What is a here? A is 1 by 4. So minus 1 by 1 by 4, minus 1 by 1 by 4 becomes minus 4. So it is minus 4. Then minus 0.5 by 1 by 4 is, it becomes minus 2, and this becomes 0. Okay, so now this is your signal. What is its amplitude? The amplitude is same. It is 1 only, because we are not doing any alterations or modifications for amplitude. Fine. So we made the range as 4. Okay, this is 4 and this is also 4. Fine. Next. Yes, now your y of t is a symmetrical signal. So now to make your x of t symmetrical, what you have to do? You have to shift your x of t. Yes, shift to the positive portion. Okay, that is the reason. Yes, now I'm going to draw x of, how much you have to shift? You have to shift, see here, the signal is, yes, should be shifted by 2 to get this by x of t like this. Means here is 0, is shifted by 2. Okay, then x of t minus 2 by 4. Okay, how is it? See, 0. What is this? This is x of t minus 2 by 4. Okay, means you have to shift your x of t by 4 by 2. Yes, now 0, for 0 you add 2. Yes, it will be 2 here. Next, for minus 2 you add 2, it will be 0. For minus 4 you have to add 2, so it will be minus 2. Okay, so now if you see the signal is like this, the amplitude is 1. Okay, now if you observe x of t minus 2 by 4 and y of t, what is the difference? The difference is only the two signals are in reverse and the point of amplitude. Yes, this is above the 0 line and this is below the 0 line. Okay, simply, yes, I can write y of t as minus x of t minus 2 by 4. Simply you made amplitude reverse, then it becomes, yes, exactly as y of t. Okay, now, yes, what you have to do? Yes, now apply Fourier transform. If you apply Fourier transform, y of t Fourier transform is y of f. Yes, minus is minus. Then if you see this, it is x of t minus 2 by 4. Here the scaling factor is a is 1 by 4. So you will get, yes, we have that property now, x of a by t is in Fourier with 1 by mod a x of f by a, like this. Okay, so now here it is 1 by 4, a is 1 by 4, so you're going to get 1 by 4, yes, x of f by 1 by 4, finish. This is for scaling. And you have another shifting concept. So you know the shifting, yes, you just multiply it with e power minus j 2 pi f into this shift factor. What is that shift? 2. Okay, so totally the answer is minus 1 by 1 by 4 is minus 4. X of f by 1 by 4 is x of 4f into e power minus j 2 pi f into 2, it is e power minus j 4 pi f. Okay, so now this is your answer. Yes, now where is that? Yes, here is your answer. C is your answer. Okay, yes, simply you have to transform your x of t like y of t. Okay, so for that, first make the range equal, then yes, by going for x of t by 4, then shift the signal by 2, yes, you'll get this. Then the difference between these two is only amplitude reverse, just simply you reverse the signal. Okay, then you apply Fourier transform. Here we used two properties, time scaling and time shifting. Okay, is the next question is, for a causal discrete LTI system with transfer function h of z is equal to 2z square plus 3 by z plus 1 by 3 into z minus 1 by 3. Which of the following statements is or are true? So, as the question is like is or are true, definitely it is MSQ question. Means multiple select question. Yes, and the given options, definitely you may get 2 or more suitable answers. Okay. Yes, the options are system is stable. The second option, the final value of the impulse response is 0. Third option, the system is a minimum phase system, and the last one is the initial value of the impulse response is 2. Okay. So for this problem is you have to check the options one by one. Okay. I'll start with the first one. Yes. Before that, you consider the given transfer function h of z, 2z square plus 3 by z plus 1 by 3 into z minus 1 by 3. It is better to write the poles and zeros. What are the zeros? Zeros. How to get zeros? Simply make your numerator is equal to 0. If you make numerator is equal to 0, you are going to get the poles as z is equal to plus or minus j root 3 by 2. Okay. Then, what are the poles? Poles are z is equal to minus 1 by 3 and z is equal to 1 by 3. So, totally you can write as z is equal to plus or minus 1 by 3. These are the zeros. Okay. So, first we'll see, yes, for the first one, the system is stable. Yes, for the systems to be stable, system is stable if magnitude of poles is less than 1. Means, is the poles must lie inside the unit circle. Okay, poles must lie, these must lie inside the unit circle. Inside the unit circle, yes. Now we must observe the magnitude of poles. What are the poles here? Z is equal to minus 1 by 3 and Z is equal to 1 by 3. So if you observe the magnitudes of the poles magnitude, all these two poles magnitude is less than 1, means the system is stable. Okay, so the system is stable. Fine. Okay, and now I'll see the second one. What is the second one? The second one is the final value of the impulse response is 0. How to find the final value? That is the final value h of infinite is limit z tends to 1, z minus 1 into h of z. So simply you substitute limit z tends to 1, z minus 1 into 2z square plus 3 by z plus 1 by 3 into z minus 1 by 3. So there is no chance of cancelling your z minus 1. So now if you simply substitute z tends to 1, this becomes 1 minus 1 is 0. Okay. So totally the final value becomes 0. Yes. So option 2 is also correct. Yes. Next. Now go for system is a minimum phase system. Yes, the system is said to be a minimum phase system if zeros lies in unit circle. The system is said to be minimum phase. Yes. But if you observe the zeros, what are the zeros? Z is equal to plus or minus j root 3 by 2. What is the magnitude? Magnitude of zeros is magnitude of plus or minus j root 3 by 2, which is greater than 1, means the zeros lies outside the unit circle. Outside the unit circle. Therefore, the system is non-minimum phase. Non-minimum phase. Okay. So, yes, the C option is wrong. Okay. Yes, now we have the last option. The last one is The initial value of the impulse response is 2. What is the initial value? H of 0. H of 0 is equal to limit z tends to infinite h of z. Okay, so now limit z tends to infinite. What is h of z? 2z square plus 3 by z plus 1 by 3 into z minus 1 by 3. Okay. Yes. You take z square common. 2 plus 3 by z square by, here also you take z common, so z square of 1 plus 1 by 3z into 1 minus 1 by 3z. Now you cancel z square. Now substitute z tends to infinite. This term becomes 0, this term becomes 0 and this term becomes 0. So totally what are you going to get? 2 by, this 2 by, here 1 into 1, so the answer is 2. Okay. The initial value of the impulse response is 2. Okay. So this is also correct. Okay. Now totally how many are correct? A, B, D. Okay. Totally A, B, D answers are correct. Okay. Only C option is wrong. Okay. Thank you very much. In the next video, I'll cover the remaining questions. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.